Hey, Mr. Manwaring and
Dr. McGee here to talk to you about series circuits.
That's right, series circuits.
What's our goal today? Our goal today is
that you will be able to talk about the advantages or the good things and the bad things about a series circuit. There's two parts to this video.
That's right. So we've got part one that we're just going to talk about series circuits, and we'll have part two where we'll talk about advantages and disadvantages of a parallel circuit. We'll talk about that later. So a series circuit is a complete circuit where there's how many paths?
Just one.
How many?
One.
How many?
I think it's just one.
One. Okay.
Right.
Now, there's some bad things about the fact that there's only one path. First of all, any burnout or break or any problem with the circuit causes the whole circuit to shut down. Shut it down.
It's down.
All right. Now, as you add resistors, though, if you add, let's say, more motors or more buzzers or more light bulbs, if you add resistors...
Did you say buzzards?
I did. But
Wow.
it's buzzers.
Buzzards, okay. Because buzzards,
that would be
not,
a bird.
Those would probably
those
be
are
an insulator.
insulators, right. So if you add resistors, that increases the resistance.
All right, well, I'll take over from Mr. McGee here. Basically, as you add more resistors, remember, more things that are using the electrons or the juice, it's going to cause them to move slower. Think about your hair dryer. If you have it plugged in, you turn it on. Usually it'll cause the lights in the bathroom or wherever you're at to dim just slightly because you're adding another resistor to that part of the circuit. So that's a big clue for that.
Good.
Some advantages that they're very simple to build, and they're easy to design. They're easy to make. If I gave you a bulb, a battery, and a wire and told you to make it light, you would be able to do it. That would be a series circuit.
Fantastic. What happens when you add more light bulbs or more resistance? That decreases the flow of electrons. We talked about that as being a disadvantage. So there's less light, less movement in a motor, okay, because those two resistors are sharing that electric pressure.
Is your house wired in series? Not usually. Only certain parts of it could be, but the majority of things are not. Because how do you know? If you turn the lights on in the kitchen, the lights in the living room usually don't go on and off when you have the kitchen lights on and off. They're on separate circuits that are all connected in one part.
Right. And if I turn my TV off, it doesn't turn the lights off in the kitchen.
Sure hope not. No. That'd be kind of inconvenient.
That would be weird.
Very weird.
Yeah. So here's an example of a series circuit. You see you've got the battery here where the electricity flows from the minus to the plus. So you've got the electricity that leaves the minus, goes through the resistors, back to the plus of the battery.
That's right.
Here's a difficult situation, though.
Yeah, this picture is a little bit confusing. If you look at it, actually, same sort of thing. You have electrons going from the negative end of the battery through the circuit back to the positive end. Even though the bulb is broken, probably it'd still light, not be all that safe because of the jagged edge. But if that little filament, that little wire right there, little coily thing was broken, then the electricity would not flow back to the battery. Therefore, it would be an incomplete circuit.
Right, and that's one of the disadvantages when you have a series circuit. If one thing goes wrong, the whole thing's wrong.
All go out, yeah.
Okay? Here's a series circuit image. I really like the image. There's only one problem with the image. The current is flowing in the wrong direction. This arrow should actually be going this way, coming from the negative side of the battery back to the positive side. Okay? Now, I'll give it a little bit of a pass because the switch is open, so there really isn't any current flowing right now.
None.
But if that were down, I would say that this arrow needs to be switched around.
I would agree with you.
Okay.
So in another picture here, we show resistor, we show the wire, we show the battery. Three very important parts in order for a circuit to work is that you got to have the battery, you got to have a way for it to flow, and then you have to have something using it up.
So I want to show you this little diagram here. We've got two circuits made, and I want you to see. First of all, you know there are a series circuit because there's only one path for this one and this one to flow, okay? This light bulb, Mr. Manwaring, there's only one here, but this one has two. What do you notice about the light bulbs?
Oh, look at the lines. One's much more brighter than the other bulb. Brighter.
Right. Very good. And you can also take a look at the pacing of those little models of electrons flowing through there. The pacing is totally different. You can see this one is clearly moving faster than this one. Now, what's going on with these amps here?
Well, we're talking about, remember we talked about, in a previous video, we talked about electron movement being measured in amps. Well, you can actually see that 0.9 amps is closer to 1 than 0.45 amps. So you can actually measure the electron flow by talking about its amps. And the bigger the number, the more power it's going to have, and you can see the bulb is brighter as a result.
Right, and you can see here, more electrons are moving through here because there's less resistance. Less resistance, more electrons can flow through. more resistance, you increase the amount of resistance, that actually decreases the flow of electron. They sort of work in opposites of one another.
Yeah, we call that an inverse relationship.
Oh, nice.
There we go. Just reviewing the goal. Students be able to demonstrate advantages and disadvantages of a wired series circuit. Hope you can do that. Stay tuned for the next video on parallel circuits. And until next time.
See you soon.